My name is Thiago Maceiera. I'm Senior Product Manager for Nokia. This is my 4th Qt Developer Days, 3rd time presenting, and I'd like to welcome everybody here. I see we have a full room, more people than I expected to see. I see at least that MeeGo is very interesting for you, or you're trying to learn what it is. I have with me Rusty.
Yeah, I'm Rusty Lynch. I work at the Intel Open Source Technology Center. I'm an architect there, focusing on MeeGo. This is my 2nd Qt DevDays. First one was last year in San Francisco. And yeah, so my background is originally as a kernel hacker, then Mozilla hacker, and nowadays a Qt hacker.
Yeah, I hope that has been a good transition for you, Rusty.
And I've worked on everything else in between, so.
Okay. So yeah, you have here a bit of what I've been doing. I joined Trolltech in 2006 and started as a developer. And then since then moved on to being product manager, which means I like to talk to people and like to hear what you guys have to say. I like to hear questions. Unfortunately, since the microphone needs to go around, we will not have the time to have many questions during the talk. But if you have a question, please do raise your hand during the talk. If you don't understand what I say or what Rusty says, raise your hand, we will repeat. Can the people in the back understand me? Okay. Can you also read what we have here? Good. Like I said, if you have a doubt, raise your hand, we'll re-explain, and it's no problem to do that. So what are we going to talk about today? I will talk about MeeGo, and Rusty will talk about Qt.
We like to keep it interesting.
So I will talk about what MeeGo is. I don't know how many of you have heard of MeeGo already. Please raise your hand if you have. Okay, how many haven't heard? Okay, good. We've got a good audience that knows what we're talking about. I'll go into specifics of what it is. Maybe you've heard of it, but you don't know what exactly is in the internal, how Qt plays a role inside it. And then Rusty will share his experiences doing development for MeeGo on a specific kind of device and under some very interesting constraints that you might find yourselves into if you're developing applications for MeeGo. The demos on MeeGo, of course, will not be inside. So when you have the break, you can go to the booths outside. Many of our sponsors are showing demos on MeeGo, including Intel. And all of the demos that you have from the Intel booth are running on MeeGo and across different kinds of devices running MeeGo. I really do recommend that you go see it and see what can be done there. So what are my objectives here? What I would like you to learn from this talk here, what I would like you to convince you is to use MeeGo and to consider MeeGo for your needs. How many of you have developed a mobile application? Good. And how many of you are developing desktop applications? Also good. And how many of you are companies deploying devices? Yeah? Good. We have a good selection of people. So that actually means I have the audience's attention. I'm trying to convince you, if you're deploying a device, to use MeeGo for your next device. Why? Well, because it's a stable Linux system. It's optimized for ARM and Atom. And we're hoping to get a nice application ecosystem around it, which brings me to the application developers. Why I'm trying to convince you to target MeeGo, because it's easier than most platforms to develop for. It's Linux. It is like my laptop running a Linux distribution with X11. And if you're not interested in developing either a device or a mobile application, what I want you to understand is how MeeGo is getting important and why you should consider for your desktop application some kind of integration. For example, data synchronization, cloud storage, so that your users can go from a desktop or a laptop into a handset, and so on. So I'm starting with MeeGo and Qt, and why MeeGo is important for Qt and why Qt is important for MeeGo. So first thing is that you might have heard MeeGo is the high-end platform for Nokia. Devices that we will be shipping soon now, I'm not allowed to say when, soon now are going to be running MeeGo. Linux devices like my N900, which I have on my pocket, but running MeeGo using a stack of applications very much like what we have on the desktop. And the interesting thing is that its Qt form is in a central piece of MeeGo. It is the part of the official API. How do you develop for MeeGo? How do you get access to the capabilities that the system provides is using Qt APIs. That means MeeGo is taking Qt to more and more devices and markets. This is why this is a symbiotic relationship. This is why it's a win-win situation for both. We're bringing to MeeGo a nice API that I hope you guys agree with me is a nice API. You guys are here because you develop with Qt, or at least are interested in developing with Qt. And now this brings you to the possibility of getting your applications, getting your name, getting your company to more and more devices, and Qt is going with it. It is going in our direction of Qt everywhere. More than that, it increases the developer ecosystem. It allows us to have more people developing for the platform, developing applications, and makes it easier for example, if a company needs consulting business because they have requirements that aren't yet in the stack, aren't yet answered for, we have the developer ecosystem, we have the partner companies to help along. So what exactly is MeeGo? MeeGo was founded in 2010, beginning of the year now, by Intel and Nokia as the merger of Maemo and Moblin. So it's the third name starting with the letter M now. And it's driven by the Linux Foundation. From the beginning, when Intel and Nokia agreed, we are going to do this, we are going to do this open source. We're going to actually give this to the Linux Foundation for the Linux Foundation to take care and make sure that it is fair and open. I'll get to that in a second. What we're trying to do is create a Linux distribution, highly optimized, highly performant for mobile and embedded devices. I'm not talking about laptops and desktops, even though I've heard of some projects of taking MeeGo onto those as well. I'm thinking of more devices where Linux has a lot of inroads, where the tentacles of Linux are going into, but we need a bit of standardization. We need a lot of effort to get into that. Besides all of this, we're trying to have a 6-month release cycle. We had the first release in April. The next one is this month, and we'll have another one April next year. For MeeGo, Openness is extremely important. We're committed to remaining open. We want to make sure that all of our contributions go upstream to the projects where they already originated. We don't want to maintain a set of patches. We don't want to maintain a modified Linux kernel or a stack of applications that is not common to Linux distributions. We want to use open standards as much as possible. And a good example of this is freedesktop.org, which was created for standardizing between Linux desktops, but also provides a lot of interesting functionality like MIME types detection, file associations. We're using all of this functionality that is open in MeeGo, and instead of reinventing the wheel with new functionality there. And more than that, we also want to do open development. So MeeGo's discussions are in the open. We have the MeeGo Dev mailing list, we have MeeGo SDK, community, and so forth. And what we're doing there is we're discussing what is required, what is the plan in the open. And a very interesting thing I found out when I started to learn about MeeGo was the technical steering group, which is the highest instance of MeeGo. And they have regular, every 2 weeks, meetings on IRC. So it doesn't matter where you are, you can join in. Maybe it's a bit too late or too early for you in the morning, but you can join in. You can ask questions to the TSG, and other working groups are doing the same. We're trying to have this open so that anybody can participate. Now, one thing I mentioned was the stack. the fact that we were fairly close to a Linux distribution. I'm afraid that you're not going to be able to read it all. You can find this online, the same stack. What I want to point out is the fact that we have the Linux kernel at the bottom, adapted to whatever hardware we have. And this adaptation is something that is part of the Linux kernel and is upstream. We don't want to maintain a fork of the kernel. We don't want to maintain our own adaptations. We have a stack of very common APIs found on Linux systems, on distributions. Like, for example, we have WebKit there. We have, what else? We have GStreamer. We have access to Pulse Audio. Package management is the one that you find on normal Linux distributions. Why? Because this is proven. We know it works. We don't want to redo it. Another very important part there is X. You probably can't see my laser pointer, but we're using X. I'll get into why in a second as well. And then we have a layer called MeeGo API. The MeeGo API is the list of libraries blessed by MeeGo for application development. And Qt features prominently there. Qt is a good deal, a greater part of the MeeGo API. We have other libraries as well, like the MeeGo Touch framework, which Rusty will talk a bit more later on. But we have mobility, and we have other functionality there. So MeeGo 1.1 is this month. Contains Qt 4.7.0, might upgrade to 4.7.1, and contains, obviously, Qt Quick 1.0 with QML. So MeeGo 1.1 is already ready to do the QML functionality that you saw this morning in the keynotes from many of our, well, mostly of our own people from Nokia. So all of this is ready already for you to use. It contains Mobility 1.02 with its backends, the MeeGo Touch framework that I mentioned, and the officially released profiles of netbook and handset. What do I mean by profile? We have a couple of interesting segments that we're trying to address. So like I mentioned before, we're not trying to address netbooks, laptops and desktops. Why? This market is well served. We're trying to get Linux to standardize and be the best in class for these kinds of devices. From what we've been talking to customers and future device deployments, everybody's moving to Linux. So what we're trying to do is give a standardized Linux distribution for these devices, and therefore create an ecosystem. Netbooks and handsets, like I mentioned, these are the two we already have released, and we have official versions for. But we also are working on connected TVs, so set-top boxes connected to the internet. And you can see them outside at the Intel booth. We have, we're targeting also media phones running Linux, so video conferencing, for example, and IP phones over the internet. We're also targeting in-vehicle infotainment. It's an acronym that you might hear if you're into the MeeGo ecosystem, IVI, in-vehicle infotainment. It basically means the onboard computer doing maps, navigation, sound, maybe playing a movie on board. The interesting thing was that the Geneva Alliance, which is an alliance of manufacturers, of car manufacturers, has chosen MeeGo for their functionality, which means MeeGo is, for these manufacturers, the default Linux distribution, what they will be running. So, I mentioned that we're using X11. I'm just going to tell you why. Well, one of the things that X11 and Linux are arguably the best supported platform for Qt. Why? Well, most of our developers are actually using it internally. Most of us actually have many different machines. So some of us have a Mac and a Windows and a Linux machine, and we have many screens, and you should see it in the office. It's very nice to see you. There was one person who had 6 screens, so 2 levels of screens. It was very interesting. He has some loudspeakers as well, so his desk was very cluttered. But it was nice to see that. But my point was that it's the best supported platform for Qt developers. That's what we use mostly. And the other thing is that for a number of years now, KDE has been helping us in the sense that this is the traditional home for KDE. KDE has been running on Linux with X11, providing us with a good wealth of test cases, of applications we can test Qt against and make sure that it's all working. Like I mentioned, we have the stock Linux kernel. We're not trying to differentiate there. And all the modifications are there. We're using well-known, well-tested libraries from Linux. For example, we're using glibc. We're using GNU core utils. We're not trying to use something different that might or might not work, and will provide incompatibilities later on. Some other, for example, Linux system that you might have heard of, they're using a very different libc, which means we have a huge problem of trying to support Qt in that because the missing functionality, things don't work very as expected. Now, with MeeGo, we have the standard. And we're using X. X is a technology that people love to hate, sometimes for not the right reasons. But we're using X and Y. Like I said, well supported. It also is a client-server architecture, which allows us to do very interesting things. One of the demos outside from our Intel friends is trying to use, from one device, show the screen on another device, both running MeeGo. And how do they do that? It's X. So we just export the view from one to the other. The protocol is done for that. So if MeeGo is standard Linux, how does MeeGo change the picture? We have the best in class boot time sequence. If you have a mobile phone, for example, I don't know if your laptops boot in 1 minute. I don't mind. I don't ever turn it off. I just suspend it. So I don't care how long my laptop takes to boot. But if my phone, I want to turn it on, and it takes 1:30, it's not going to work. Imagine that you get home, you just want to relax, you turn your TV on, and it takes 30 seconds before you see anything. This is not going to cut it. So what we're doing is that we're optimizing the boot sequence, making sure that it boots really fast. On netbooks, we have, how much are we get there now, Rusty?
Well, it depends on the hardware. As low as 4 or 5 seconds.
4 or 5 seconds.
You have various things that are bottlenecks. So if you have a good SSD, then you won't be bound I/O. And
in 4 or 5 seconds, from pressing the power button to having a ready system.
And if you don't have, if you have a cheaper hard drive, then it's going to take more in the range of 12 to 15 seconds.
Good. We're trying to optimize the packages that you have available, making sure that everything is optimized. So the ARM builds, for example, they're targeting on v7. We're not targeting anything lower than that. We're trying to get the most out of the hardware. We know that if we are in an embedded system, we have slow CPUs, the memory bandwidth is a problem, I/O is a problem. So let's try and get the most out of it. We're using ARM v7 instructions, and on the Atom side, we're optimizing for the best that it has in terms of extensions. We have security framework coming in, so many needs we have for on many markets to ensure that applications don't take over, or they're allowed to, for example, show something or play something on a car radio. Not all applications can be allowed to do that. So security framework is coming for that. And the other thing is we're requiring OpenGL and OpenGL-ES. Displays are big. There's a lot of pixels. So you heard this morning, many of the technologies we have in Qt are targeting, therefore, OpenGL and OpenGL-ES. And MeeGo is requiring this as well. We don't have Qt 3 support. You also heard this morning, please move on from Qt 3 support. But we also have a lot of services coming in from that stack that you saw before. You have many services coming in from the system that can provide you with extra information. Location is a very good example. So you can get access to the GPS information, maybe some even other forms of location. the database of context information stored between applications that allow you to do semantic matching of information. Messaging, document gallery. This might remind you from the functionality we have in Qt Mobility. There's a reason for that. It's because mobility is targeting many of the same areas, and MeeGo is taking profit from the fact that we're doing that and also bringing more new technology that is not yet in mobility, but hopefully will be soon. So how do you work with MeeGo? The SDK based on Qt Creator, similar to the Nokia Qt SDK, is coming. We're using RPM packages. So like I said before, standard Linux packaging system, well-known, well-proven, and Linux Foundation. It's the Linux standard base as well, the same one used there. You can do on-device emulation. If you are targeting Atom platforms, you can just run natively with Zephyr. If you're targeting ARM, you emulate with QEMU. And how is the full distro built? It's using the OpenSUSE build service, another well-known, well-tested functionality from the open source community. We're just building on what exists, putting everything together to create the best functionality. The MeeGo compliancy is there for two reasons. It's to get device manufacturers to create the installable, the functionality that applications need on all devices, to standardize on functionality, to standardize on features available. And if applications adhere to these guidelines, they are then able to install and work on a breadth of many of devices coming. Why should anybody do that? Because it gets you access to the brand. You can call your device MeeGo TV something, your company name. That would allow you to say, I accept applications being installed, MeeGo applications can be installed, and you participate in the ecosystem. More than that, we have application stores. Obviously, the core, the MeeGo core, where repositories come from what the distribution is built of. We have the open source community producing applications, many of which are available on netbooks and from many different devices. We have the Nokia OV store, obviously for Nokia devices. And we have the app from Intel, which can be licensed to create application stores for specific devices. Yes.
Okay.
So that was my part.
Yeah, so I come to talk a bit about my experiences in creating a new tablet user experience. So starting off, several months ago, I was asked to kick off a new project, to create a new product that had a lot of very interesting restraints. So first of all, it has what I would say an unconstrained UI design. So what I mean by that is that I have a set of UI designers that have been itching to create a UI that they really wanted, not just another version of GNOME, a clone of Android or a clone of iPhone. And in doing that, then they've basically dreamed up some fairly interesting stuff that doesn't really fit in any of my existing toolkits. Another thing about this project is I knew from the very beginning that not only would I have some rather different UI designs, I knew that the UI designs were going to evolve significantly over the project. So I had to expect that many times throughout the project, I would get UI designs that would have just a minor tweak to it that could have a huge impact to the implementation. Another thing is that almost in the very beginning of this project, I had to show something where it looked like it was working. Something that came up rather rapidly was there was this Computex show I'm sure quite a few have heard of. And I was put on the spot to have a demo working when I was just trying to get my initial plans together on what exactly the device is. And then, of course, as a business interest on this just went through the roof with Apple coming out the iPad and the iPad being a huge success. Then there was huge demand for executives to walk into a room with another executive and be able to handheld walk them through something that that shows what we're talking about. And of course, I knew from the beginning it was going to be insane tight work schedules, and the schedules got tighter over time. So talking a little bit more about this. So what I'm talking about is a tablet. So this is a device that is all direct touch with multi-finger touch input. This is a low power device, so this would be built on, if you've heard of, we have a low power architecture we call, the code name is Morristown, and there's a couple of follow-ons to it. So this is one of those type of devices. And then when you start looking at the way that the designers envisioned this thing being used, is going to have lots of very tight interaction with social networks, be it Facebook, or it really matters what locale you're in as to what the social network site is. But the idea is to bring in all those social feeds and present it in a way that it makes the device more usable. And then last but not least is that there was the absolute promise that you had to have completely uncompromised web surfing. So the web browser on this had to be something on par with the desktop, which, considering it's a slightly smaller form factor and it's low power and all the other constraints, makes it a bit interesting. So when I was given this task, I started to look at what I had to work with. And at this time, this was at the very beginning of our of the MeeGo 1.1 development cycle. So looking at the roadmap, we had this thing called MeeGo Touch framework. So MeeGo Touch framework it's a lot of things, but one of the things it is a set of widgets using a QGraphics view widgets, so that you can make a QGraphics view application, but then have all your standard type of things like dialogues and buttons, instead of just having the raw primitives. But it also included several other kind of core infrastructure things that you need in order to make a full experience. Like, for example, a compositor that was very much tailored to the user experience. Other things are an input framework, so you can have pluggable virtual keyboards, input method editors, a new kind of notification system, a theme engine, and various application services. The other thing on the roadmap was, of course, Qt4.7, which everyone here is probably quite familiar with. But of the 4.7 stuff, I found Qt Quick to be especially interesting. Keep in mind, though, this is when QML was quite experimental, and every time I do a git pull on my Qt tree, the APIs would change. So it was a bit scary at first, but it was interesting. And then, of course, I knew I had to have multiple touch points and gestures and all that working. And it was obvious that Qt made that fairly nice, fairly easy. And then, of course, you have all the normal core application components. The other thing that was in the roadmap that looked interesting was Qt Mobility, and specifically at that time is the Qt Mobility 1.0, and then also having access to what people were planning on the next couple of years. I could see lots of interesting APIs that were, for the most part, APIs for things I needed, like how do I play files, like music, video, all kinds of things. So immediately, a lot of my colleagues assumed that, well, let's just use MeeGo Touch, and this basically becomes a big handset. So in the handset user experience, it's all MeeGo Touch based. But I had some complications with that. So one of the things was, when you looked at the UI design for the way my home screen worked and my lock screen, and I have a range of core applications that are tightly integrated with the home screen, the look and feel, the way the widgets worked, didn't really map to anything that existed in MeeGo Touch. It was all rather custom. And so that basically left me with a couple of options for MeeGo Touch. One was I could patch it heavily. And the other option is I could just look at what the guys did with MeeGo Touch and just implement a whole new set of widgets and use those widgets. But it had a major constraint, and that was that we needed to have third parties be able to bring in their MeeGo Touch applications, which means that I could not touch any APIs or ABI. So my hands were a bit tied there. And it was kind of unclear to me. It was unclear to me how far I could take patching MeeGo Touch without breaking API and ABI and get a fundamental different look. And considering the extreme short amount of time I had, that was a bit scary for me. So just to kind of point out the differences. So on the left-hand side is a screenshot of the home screen for the MeeGo Touch handset UX. So this is the release is coming out right now. And you have basically an application switcher is what is in the center of the screen that you can flick back and forth. And on the bottom, you have your hot buttons for launching applications. Fairly typical home screen. To the right of it is what I showed at Computex using all this stuff. And this is a home screen where you can flick left and right, and you have a whole bunch of these different panels. And for any one panel, you can flick up and down, and you basically have live content that's always streaming in. So one panel will be your photos panel, and there you'd be able to see quick access to photos you recently looked at, feeds in from Flickr for your friends that have just published photos, access to be able to point to a photo and say share it with this networking site. Same kind of ideas with videos, and then this concept of a friends panel that merged together all the different social networking stuff into one live feed. And when you look at it, I guess the key thing to take away is that nothing on there is really a standard button or dialogue, or it's all rather custom. And of the various other applications, they're more like the thing on the right than a standard application. So what I decided to do was a rather big gamble, and that was I spent a little time, well, I probably spent a week of just locking myself up and playing with QML and seeing what I can do, and convinced myself that I could probably make just about anything. I could probably make anything in QML, and it looked like the trolls were investing heavily enough in it to where it would arrive in time for me to use it. So I decided to use QML for this core user experience. It's a home screen, it's a lock screen, and a core set of applications. But for the things that were missing in QML, I basically decided to bridge in several different technologies from MeeGo Touch. So basically it meant writing a series of plugins that pulled in native components, and then also using Q2 mobility wherever I could. So I'm going to walk through just several examples of things I had to touch, and kind of point out how easy or hard it was. So one example is in a MeeGo Touch app, you have this concept of a standard status bar. So on the very top of the screen, you have something that this is a screenshot of, the type of thing that has your wireless signal strength, your time, a list of notifications that are trying to get your attention. And the way that this is done in MeeGo Touch is that instead of having, so first of all, in MeeGo Touch, the window manager doesn't render anything, any kind of decoration around a window. Everything is rendered inside the application in order to do the various kind of interactive animations. But instead of having every application implement their own status bar, or every application registering and waking up for all the different events to get a different time and all that, the architecture uses this thing called System UI, which is this back-end process that does several things. But one of the things it does is it renders the status bar into a pix map that's explicitly shared, and then it provides a dbus service where you can ask it what is a pix map ID. So In QML, I basically did the same thing that MeeGo Touch did. So I implemented a Q declarative item, and in that Q declarative item, I interrogate the server to ask for the shared pixmap ID, use the Qt mechanism to say, give me a Q pixmap from a native pixmap, paint it on paint, listen for damage events, and the end result is, once that's in place, then in QML, it just looks like you have another element, like rectangle. And it's that easy, you know? You just stick at the top of your application, and it's even easier because I create a new element called window to put all the boilerplate stuff in it, so every application developer doesn't have to go and re-implement. And I put the status bar on the top without the application developer really having to worry about it, and then listen for when it goes full screen and then hide the status bar. So basic, simple QML. Another random thing. In MeeGo Touch, you have this subsystem called ContextKit, which is a mechanism for publishing and subscribing data. And one of the things ContextKit is used for is in the internals for MeeGo Touch. It listens to a particular context item to be able to be notified about orientation changes so that the application framework can automatically change the orientation of the app. So on my system, I already had the drivers and everything in place so that it's publishing this value. But from QML, what I wanted to use was this new orientation sensor as part of the Mobility 1.1 API, which is very nice to use. So in order to use that, in order to get that data in QML from ContextKit, it was just a matter of subclassing this thing called a Q sensor backend. And basically, I have a hello world mobility sensor that just listens for ContextKit changes and then translates that to the mobility sensor API. And then you get, in QML, you get to use this thing called an orientation sensor, which is really easy to deal with. So you just declare orientation sensor. You have some properties on it, like you have this property called active, so you can turn the sensor on and off, which is useful for things like deactivating or to lock the orientation so that you no longer get values coming in. You listen for the reading to change. And then in my top level window, I have this property called orientation that then drives a state machine to do the animations and effects for the application changing orientation. And you can see how I just add a property alias called orientation locked, that all that is just pointing to the method on the orientation sensor to activate it or deactivate it. So I have a very similar API to MeeGo Touch where you, in the application, if you have something like a video player that you want to lock into landscape, then you would just set the property to make it locked. So now you're no longer going to respond to the device changing orientations. And then you would just manually say orientation is top up. Some of the other things. So when you do QML code, eventually you need to create what I'm calling an executable wrapper. So in the development of the QML, you just use QML Viewer, which has got a lot of nice features to make life easy. But you eventually need to have some native code that, at the very least, is opening a top-level window, filling it with a Q declarative view, pointing the Q declarative view to your initial QML file, and then you're off and running. But in order to make this work nice in a MeeGo Touch system, you have to do a little bit of bookkeeping. Like in MeeGo Touch, as I mentioned before, a MeeGo Touch application is edge to edge. The window manager doesn't paint anything. And so because we have a need to support legacy applications that expect a window manager to have an X or a button to return home, then if the window manager thinks that you're not a MeeGo Touch application, it's going to go and paint a pretty border around it with a big X and something that looks like a home button, which would destroy my app. So you got to do things like make yourself full screen, set up the window properties so that you're not, so you explicitly ask for no decorations. And then some other things I found that were pretty nice, which really isn't specific to MeeGo Touch, is there's a lot of reasons why it's nice to be able to get to your main window from QML. So for example, in a MeeGo Touch system, so you tend to have some big button that's a home button, and whenever you touch that button, it returns to the home screen. But what's happening is it's just doing a standard minimize event. But from QML, I couldn't find anything to say minimize my window. So that was just a matter of taking my main window, adding a method to it for go home, ensuring that I mark it as invocable so that I can get to it from QML, that it's exposed to the metatype system. And then I use this thing called a QDeclarative context in order to make that element accessible inside QML. So in my code, I have this thing called main window that's globally available everywhere. So I can call main window go home, and the app minimizes, and it works. And there's a whole bunch of other nice things that, if you need to get to some functionality, you can add a little bit of functionality to your main window and then be able to call it from QML. It's quite nice. Another thing is, one of the things that MeeGo Touch provides is this concept of a application service. It happens automatically, and it's only an advanced MeeGo Touch app that would normally subclass us to get different behavior. But this is the type of thing this is the type of component that allows you to do things like make your application a singleton. What I mean by that is you have a launcher, you launch the app, you go back home, you keep launching the app, it would just raise the app. It doesn't start 5 different instances of your photo viewer. And then also, it allows you to do things like do some simple IPC mechanisms. So I can have my photo viewer up and running, and then another app can call to the photo app and say, go load this photo. Very similar to how you launch, if your browser's running with Firefox or Chromium, you can try to go on the command line, you can run it again with an argument for a given web page, and it'll load that web page in your running web browser. So to do that, that's basically something where you have to go and subclass this MeeGo Touch interface and add a little bit of QML magic, and voila. So beyond that, I had a bunch of other things that I did, and this just kind of walks through, but I'm kind of hoping to kind of give you the idea of how it was actually fairly straightforward and easy to get access to all your native components. I mean, that was one of the things that I know a lot of my colleagues were quite scared of when I started going down this direction. Was they look at QML and it's like, okay, great, I have access to a rectangle, I can animate it. It's not much I can do there, but it ends up, it's really easy to take native code and expose it to QML. So for example, we created a model with various methods on it to have access to the Bluetooth backend. So exposing, controlling, configuring Bluetooth. So I have a settings UI that's able to do the pairing of Bluetooth devices, sharing files over Bluetooth, that kind of stuff. Another thing is we created a generic, what we called media model, to access any of the videos, music, photos on the device, because part of the core user experience was 3 different media applications. Another thing was, in order to make the rich media apps I was being asked to create, it wasn't just a list of videos, but it tended to have, if it was movies, have synopsis, director info, all kinds of metadata that you don't have in the file. So we went and just using native, regular C++ Qt code, create a class that was able to integrate with a couple different social backends like Last.fm for music data, and another site we have for a license to for the video data, and then export it to QML. And then from QML is easy enough to when you create the view of your movie, to be able to ask it, and give me the synopsis data, director information, and have a nice UI. Another example was, in the home screen, I have part of one of the panels was a view into all your pluggable devices. So if you had any USB devices plugged in, then you would see a list of them, and you'd have the ability to call sync on it and other types of things. So in MeeGo, you get to this data via this thing called udisk, which all the modern Linux distributions have moved to. And this is an example of a dbus service. So to make that available on QML, it was pretty much running the, what's that command to be able to generate from XML file?
XML to CPP.
Yeah. So it's basically an exercise of XML to CPP to get, a set of implementation files that represent this dbus service, expose it to QML, and voila. There's a couple other examples. So obviously you need to have access to all the applications on the device. So there currently is no mobility API for this. So creating a model that pulls up all that data from the desktop files, all the metadata, and is able to point to the icons so that you can do different visualizations of how to represent all the applications on the device so you can launch it. And then another example was creating a live window model. So I had the same need as everyone else to be able to have nice visualizations of running apps. And so implementing that in native code, doing all the low-level X code to be able to do the texture from PixMap and redirect it and all that jazz, that was a bit complicated. But from the QML space, it was just a simple data model that the data coming in would have a text string, which is a title, and a PixMap. And so then you could create a cover flow or whatever kind of UI you want to visualize the applications that are running. So, has it paid off? Well, I didn't get fired. Oh, thank God. Yes, it has absolutely paid off. I'm glad I took the gamble. Qt and QML has come a long way since then. So now it's actually quite nice to use. It's nice and stable, and it works as I expect. But what it allowed me to do was have this natural separation of the UI from the implementation. That's something I always strive to do, but it always works out so that over time, the core logic gets all tied up in the UI. And so you get to a point where when you need to change the UI, at least from my experience, it gets quite hard. And the more you want to change the UI, the more you're forced to just go and start all over. But with this model, with creating these separate native components, exposing the QML, then it made for a nice separation. And part of that allowed development to move forward nicely, because in the cases where I had the luxury of having multiple developers working on one component, on one application, you could have one person that totally focused on the UI, another person that focused on the back end. And for the person that's focusing on the UI, inside QML, it's very easy to make fake data. You can just write it directly in the text file, and you can instantiate a list model, put in your list elements with representative data of what's going to come out, and then start running with the UI, which was important because, like I mentioned in my case, this is an example of where the UI design was rapidly changing, and how that would work usually would be the first time I had something that kind of looked like it worked, my boss would look at it and it'd be okay, but then his boss would look at it and it'd be, oh, no, I hate this. And it would, so it was almost guaranteed you have 2 or 3 iterations of, okay, throw that away. But with the separation of UI and the back-end data, the person working on the back-end data, the UI, I never had a case where the UI changed so much that it really changed the back-end data. You may have to expose a slightly different set of properties or something, but that work was pretty much unchanged. And the UI, yeah, quite often we have to start over. But with QML, you get a couple of days, you can whip out a UI. It's easy with fake data. And then eventually, the backend, the real backend comes into existence. You marry it to the real data, and then it's kind of magical. You have a real application. So yeah, so this product is still in development, and I unfortunately can't show it because I'm not going to be the person to do the big splash. I'm not a marketing person. But it has successfully allowed me to deliver a rather radically different UI that didn't fit into any of my giving toolkits, and implement this on an extremely accelerated timescale. So what's next? So I got a couple points here that I just want to highlight some of the things I know I need to go figure out how to deal with. And I bring it up here because I'm hoping that maybe I can collaborate with some people here and instead of just writing the code myself, have something like Qt components or something, have something I could use and I can maybe donate into. So one of the things is, so I mentioned MeeGo Touch has this theme server, which is basically a service for caching pix maps. It's called mThemeDaemon. I know I need to have all my images loaded from it, and right now I have an image provider that all the places where I'm loading a given image, I use a URL for an image provider so that I can replace the images at any given time. It's not hard coding to a particular image, but it's still, every application is just loading this. And so that if you have all the applications, for example, using the same top-level toolbar, I'm wasting memory. So that's one of the things I want to do. Another one is the Qt mobility is moving rather rapidly, and I'm looking at all the stuff that's available in mobility now and realizing that there's several things that are awful close to the stuff we had to do. So I mentioned I had this media model that I needed to implement my different media applications. Well, in Qt Mobility, they have this thing called Document Gallery that looks pretty interesting, and it looks really similar to what I created. And I'm hoping that maybe I can try to use that, and if anything, just push patches in, try to add functionality that's missing. Oh yeah, actually, one of the bigger ones I've already heard somebody touch on once is I think QML needs a better mechanism for theming. So I already know how to take care of the situation that all the images are coming from a theme server. So you could change the theme and you get different set of images. That's no problem. But it's very easy. I mean, it's one of the things that makes it so easy to create a UI in QML is you want to have this background color, you just declare it. You have a rectangle, item, color, colon, pound, 717171. There you go. But every time one of the developers does that, whenever we need to change the theme, it's not a workable solution to have duplicate copies of the QML files. So I'd like to find a solution for being able to pull that data out of a theme. I know people are talking CSS. I don't know, maybe I'm a bit scared of CSS because I'm already hitting some performance problems with the MeeGo Touch side, where loading too many style sheets is causing I/O problems. But some kind of mechanism. So
back to me.
Yeah.
Just to conclude, guys, how do you contribute to MeeGo? First of all, upstream development. We're not interested in forking projects. We're not interested in developing your projects inside MeeGo. What we want is to use existing projects and make sure that they thrive in MeeGo. So for example, Qt is a good example there. There is no specific fork of Qt for MeeGo. It's all happening upstream. And also the same thing with the Linux kernel. There is no MeeGo kernel. It's the Linux kernel with the contributions from MeeGo. I said it before, we have mailing lists, they're all public. Meeting minutes are public. Meetings themselves, most of them are public. MeeGo Core requires open source, so anything that belongs to MeeGo Core is therefore in an open source project. And we're very much interested in seeing people with the skills below here, so we can continue to grow the ecosystem. How can you adopt MeeGo? You can make your MeeGo application. You can make your MeeGo device. You can make your non-MeeGo application that talks to a MeeGo device or MeeGo application. And if you need more help, well, we've got the Linux Foundation there to talk about licensing, how we can use the brand, what they're thinking of going forward with this. We have Intel, Nokia, the Linux Foundation, and other partners for market opportunities, what we might be thinking of. And we have a number of partners, some of which are in the exposition area for consulting should you need it. And how can you obtain it? These are the URLs. You can get the actual releases from the website. But if you want anything like the daily build, it's also available. You can get the latest source code before the release. So that was what I had to say. Do we have questions?
Mike is coming.
Hello? Hello?
Yeah, we can hear you.
Which part of the first shipping MeeGo devices will not be open source?
Did you catch that?
Which part will not be open source of the first MeeGo devices? The problem is first to find out which devices those are. Right. I'm not at liberty to say what is in the first Nokia MeeGo device. I can't tell you yet.
No problem.
Right.
But it would tend to be...
That's okay, but there must still be plans on which closed source parts.
What I can tell you is the following, that MeeGo compliancy requires that any device calling themselves MeeGo ship with the MeeGo core, which is open source. You might have modifications. So for example, a specific device, and hypothetical here, I'm not talking about any specific.
Yep.
You can have a graphics driver that is proprietary because you want to get the most out of that. We try not to, but it could happen. And you could have specific hardware capabilities which are not yet open source. The application layer themselves is entirely to the device's choosing. There is the reference layer, so you see the netbook reference, you see the handset reference. Those are applications available for everybody. But should the vendor decide to have their own look and feel, they can deploy their own applications. What they are required to do is offer the API and the ability for applications to hook into that.
Thank you.
Yeah.
A few days ago, I took a look at the AppUp website and was looking for Qt applications. And I was really surprised because there was no single mention about Qt development of applications for MeeGo. Even a single mention. There was obviously a section about how to develop applications for AppUp, but nothing about Qt. Can you comment on that?
I don't know anything about it. But the guys who are manning the booth are part of that group that runs that site. So I would recommend going to the booth and saying, what's up?
What's up with AppUp?
Yeah, what's up with AppUp?
We have a question in the back after.
Hello, and thanks for the introduction.
Thank you.
Suppose I'd like to develop a device.
Can you speak louder, please?
Suppose I'd like to develop a device, also designing the hardware. And suppose that I would like to put MeeGo on this device, of which I also design the hardware, which my company is not doing, but a customer of ours actually is. What price point are we talking about for hardware boards that I can run MeeGo on? Is it more like $10 or more like $100?
That is a tough question. So what price point are we expecting? Well, it is up to you. What we are doing in MeeGo, we are requiring fairly high-end kinds of devices. So like I said, we're talking about ARM v7 on ARM, and we're talking about Atom chips. But this is what we are supporting. if you and your client have a specific hardware which is a different price point, different kinds of hardware, you could be talking even about a different architecture, you will have to do the deployment yourself. What we support right now, like I said, ARM v7. I can't talk about specifics of price point. That you need to talk to the silicon vendors.
I think the CPU probably is not going to be the place where you're going to be hit. What you need is a good GPU, because as you can see throughout all of our technologies like MeeGo Touch, you need to have OpenGL, OpenGLS. If you don't have that, then you're going to have a hard time using this.
You mentioned a security framework, security infrastructure being built into MeeGo Core. Which is the security target of that? Are you aiming to provide security for the device, as in sandboxing, SE, Linux policies? Are you aiming to provide security for the handset manufacturer, for the provider, maybe as in terms of signed bootloader, signed applications, or security for the actual user, as in supervising what applications actually do on a device and not send every piece of personal data away?
Yes.
Yes.
To be honest, it's a little bit of all of those.
Yes.
So there's an aspect to it to be able to do sandboxing. So you have manufacturers that want to have third-party apps that can run in kind of a sandbox area to limit the damage. You have the need to have signing of packages.
Yes. Verifying that they're coming from a trusted source. So if you want an upgrade, that the upgrade is coming from the same repository you came before.
Yeah. So that framework is still in development, and actually you can see it. You can have access to the code right now in MeeGo. And my understanding is that it's targeting the 1.2 release. So we're just about to start the 1.2 development. So in the current images, you're not going to see that framework. You're going to see a standard Linux security model.
So if you want to learn more about this, I actually, and for everybody here, recommend attending the MeeGo conference in Dublin in about a month's time. And there will be a double session on what the security needs are and how the security framework is trying to solve these issues.
And all the key architects that created this will be there from both Nokia and Intel.
I was missing a comparison between other embedded Linux systems like OpenWRT and OpenWRT. It's a click-together embedded system for Linux system. What are why is there a need for MeeGo, and what does MeeGo better than all the other, especially embedded systems?
I don't even know which system this is what you're talking about. When you started asking the question, I thought you were going to ask about Android, how it compares to. This one you mentioned, I don't have any specifics. I don't know about.
I mean, I can speak in general. So you have things like Open Embedded, which Intel, of course, is heavily involved in. I think that for a truly embedded device, there's kind of a level of functionality to where it's better to use something like an Open Embedded, a toolkit that builds up everything you need in one basically build system. But eventually, I can tell you from experience, as the functionality gets higher and higher and higher, and once you start getting to the level of MeeGo, which is full Qt, full mobility, it's really, you really basically have a full desktop type functionality. And then things start getting really complicated trying to maintain this in a true embedded build. And then also, typically when you use something like an Open Embedded, you're making a very specific solution that you don't have this huge ecosystem that depends on having a contract on all these different components, on all these different versions being there. So for every device, you probably build it a little bit differently. With MeeGo, you get a very standardized look at the operating system to make it easier to have a big ecosystem.
That's exactly the point. So MeeGo is also targeting the ecosystem. You might look at some of the choices that MeeGo made and say, maybe we could have gone without this so that we can save on memory, we can save on footprint. The reason why these are done, these choices one of the reasons of many is exactly so that we have the possibility of creating an ecosystem, standard Linux applications, and also benefiting from existing applications. I think we have time for one more question, and then Rusty and I will be available for talking. You can come to us. We'll be in the tech lab upstairs just afterwards, or you can come to us anytime you meet us in the hallway.
I have, in fact, two questions. One is short. When do you think, talking now about the mobile side of MeeGo, when do you think a stable version like the one from Google, the Android or the iOS, will be on the market? And the second question is, if you just give me 5 reasons to use MeeGo and not Android and iOS.
Well, we can't speak to people's devices releasing, but I can say that the MeeGo 1.1 release, which is finalizing right now, gives a vendor all the stuff they need to be able to create a device. And then it will be up to a particular company's business model on when they think they want to release something.
Mm-hmm. So you asked for 5 reasons. I'll be a bit hard-pressed. Well, one is cute, and you're here, so that is a reason for you. The second is, well, can I say second is QML? Go ahead.
As a person who had to do the initial port of Intel to Android, one of the huge advantages is that the community is open. It's not, I gotta be careful not to get myself in trouble. It's not a quasi-open project. You're not introduced into a room and you only talk to one vendor who then handles all your conversations to other people. You're in the same room with everyone. You have full access to everyone who's contributing. There's nothing hidden. Yep. That's a huge one. Yeah.
Two. You have sorry. In the microphone. But we can talk more about more reasons later.
You have also closed source in MeeGo. So it's not everything
well, actually,
open source.
Actually,
is that the same in Android? So I don't
there's no
get your
closed
response
source
on
in
that.
MeeGo.
MeeGo Core
the MeeGo
is entirely
Core is
open source.
Okay, completely.
So completely.
Yes.
Now, when somebody like a Nokia or one of the many other vendors that are creating a product, they'll go and add various components that they want to be proprietary for whatever reason.
But MeeGo Core should be enough for a device to be shipped, and it's entirely open source.
Okay, so
we can talk about more reasons. We can talk about this offline. So I want to thank everybody for coming.